Hello and welcome to the relearning for transformations. Please make sure that you put your date that you've taken this on here. Make sure you put your name on here so you can get credit. If you're looking at this video and you don't have the paper with you, you can write it on a loose leaf piece of paper if you'd like. Otherwise, there's a copy of this piece of paper in the blue box in the back of 1029. Let's begin. There are 4 types of transformations. Transformation is the general overall topic, but there's 4 types. There's reflection, rotation, dilation, and translation. Please note that translation is different than transformation. They are all transformations. The translation we'll get to right now. So when we're looking at this here, translation is a type of transformation. And the transformations move these figures all about. Either they flip them, slide them, turn them, or make them grow bigger or smaller. The translation is also called a slide. So the whole thing will be moved in a section different ways around here. And how it's moved is right here. 5 units to the right. This is to the right and up. Or we're taking our x component of our point, we're adding 5 to it, and we're going to take the y and add 1 to it to get a new point. So let's explain. Down here we have point T. If we take this point 5 units to the right, 1, 2, 3, 4, 5, and 1 unit up, that gives us our point right here of T prime. If you take a look at T right here, it is a -1, -1. T is -1, -1. We're going to transform that. We're going to use these rules right here. So our new point is -1 plus 5, and y, which is our -1, plus 1. So a -1, which is our x, plus 5, and a -1 plus 1. So our t transformed to -1 plus 5 is 4, -1 plus 1 is 0, and that gives us our point right here. This is 1, 2, 3, 4 units, and it doesn't go up or down at all. So that's our point. So those are our rules, x plus 5 or to the right, and 1 up. So we're going to do that with the g as well. 1, 2, 3, 4, 5, and up 1. And then we put our g. We need to make sure our prime notation in here, because it's not g, it's g prime, g prime. We're going to do the same for b. 1, 2, 3, 4, 5, and up 1. This is b prime. We could have put our coordinates, which are these type of things, for B and for G, and added 5 here to get our points, but we can always just count, which tends to be what most people like when we do our transformation. Use our information here and draw our new triangle, and you can see how it slid from here and up just a little bit. When we look at reflection, we're talking about a reflection in a mirror, and we always need to know over what. Where is our quote unquote mirror? Right now it's the y-axis, which is right here. So when we look at the mirror, we always see backwards of what really is. So if someone were to look at me, it would be different than would be looking if I were to look at myself in a mirror. So I'm going to label these points. This is A, B, C, and D. So we can see clearly what's going on. When we're looking at this is our mirror, each point is exactly the same distance from our line of reflection, So B is 2 units away, 1, 2. So B prime will be on the other side of our line of reflection and do 2 points, 1, 2. This is B prime. So they're on opposite sides of our line of reflection, and they're the same distance away. C over here is 1, 2, 3, 4, 5, 6, 7 from our line of reflection. So C prime will be on the other side and it'll be 7 units away. 1, 2, 3, 4, 5, 6. And right here is C prime and that's 7. D, 1, 2, 3, 4, 5 is 5 units away. D prime, 1, 2, 3, 4, 5 is right here. Now the tricky one right here is A. A is actually on the line of reflection and it's not on, we're not looking for either side. Our A prime will also be the same. So we're going to connect our points. It's not any distance away from our line of reflection, therefore it stays the same. As you can see, it's like it flips over our line. This is a flip. When we're looking at our rotation, we're looking at this. There's a couple of informations that we need to know. We know from where. It's about the origin. Right here is our origin. Our 0, 0 is our origin. And we're talking about clockwise, and we need to know how much, 90 degrees. So when we talk about rotation, we talk about turning. Turning equals rotation. So how do we turn? Well, we have clockwise. Clockwise means that we're going around this way on our clock. We start here and we're turning around. So in our problem, we would start here and we would move our figure around. This is clockwise. But here, we're talking counterclockwise. So we're going to go against the clock, counterclockwise. And we need to go 90 degrees. So we're going to end up right over here in this quadrant. Now there's a rule that goes with that. We take our point x, y, that's any point that we have on here. We're going to rotate it 90-degree counterclockwise. And what happens is that our x and y get changed. Whatever is in the y ends up in the x, and whatever is x is in the y. So when we do this, we need to, the other thing that will happen is we have the opposite of y. So if we were to take this point and rotate it over here so that it creates a 90-degree angle, our point will be somewhere over in this direction for A. It's like we have it on a string. We're creating our unit, our circle all the way around. So we're going to take this point, we're going to move it along our arc that we have here, our radius that we have. So when we look at this, we can use this rule to be able to find our new points. So A is 4, 7. B is, I believe that's 8 and 5. And C is 9 and a -3. So we're going to follow our rule, which means that we're going to change this. And this will allow us to move our point over to this quadrant that we have here, going from 1, 2, 2. So when we do that, we need to change our x and y's around. So our y is right here is 7, so it's going to be in the front part. And then the second part we have in here, the 4, will be over here. And then our rule tells us we should take the opposite of the y, the opposite of the y. So we're going to put that in here. It's a -7 and then up 4. 1, 2, 3, and 4. Oops. Yeah. So this becomes our A prime. As you can see, that's right along our arc. So if we were to measure the angle from here to here with our vertex, those are our terms that we need for our quarter assessment, is a right angle. But we're going to move that triangle around. So let's see where the next one comes in here. For the counterclockwise, we have 5. Our y gets put in our x spot. Our 8 gets put in our y spot, and we take the opposite of our y. So we do -5, and then we go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So this becomes our B prime. And our C, we flip them around. We take our Y and put it in our X spot. Our 9 goes over here, and then we take the opposite sign of our 3. It's a positive 3. Bless you. Bless me. So anyway, so we're going to look at this here. We go to 3. It seems a little off, but you'll see that it works out. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that becomes our C prime. So if we connect those, A and B are connected together. You can see how that is turned directly over to our section. So the other rules that we need to keep track of are rotation of 180 degrees. So we're going to take our figure, we're going to rotate it 180 degrees. And it can be from anywhere. It's basically we're going opposite quadrants. So if we start here, we go over here. If we start here, it goes over here. And we're rotating around on a circle. So what's our values for this? When we take our X and our Y, the rule is that we take the opposite of X and the opposite of Y. Just like we flipped them over here and we took the opposite of Y, we're going to do that for both problems here. For 90 degrees clockwise, we're going to take our point, which means that we're going to take our figure and we're going to turn our figure that way, all the way around. Go around in our unit circle, our circle that we have. And in here, we're going to flip our values and we're going to take the opposite of the X. And 270 is where we're going to move it 3 quadrants. We're going to put it way up here. And if we take our point X, Y, we can also here, we just move 3 spaces around. So we 1, 2, 3 quadrants. When we do that, our value will be the opposite of Y and X. And if you notice, these are both the same up here. This one and this one are the same because going clockwise and going counterclockwise are both similar. Just making sure that I'm telling you right. Yep. Okay. So on number 5, we're going to do this. We're looking at dilation. Dilation. So we're going to take each of these values at here and we're going to have a scale factor of 1/2. So each point A is -2, 2, and we're going to scale it down, which means we're going to shrink it. We're going to multiply each section by 1/2. So 1/2 times -2 will give us a -1. 1/2 times 2 will give us our 1. So this A point becomes scaled down to right here, and this is A prime. T is 4, 2. 1/2, 1/2 times 4 is 2. 1/2 times 2, half of 2 is 1, and our T is 2, 1. Our H is 2, -2. We're scaling it down by 1/2. Half of 2 is 1. Half of -2 is -1. And we're going to put that's 1, -1. That puts us right there as H prime. And then you can see right here that M will be right about here. So M, our point is -4, 2. 1/2 of 4 is -2. 1/2 of 2 is 1. -2, 1. So when we have a scale factor less than 1/2, it shrinks it down. We connect our lines, and there's our new figure when we've shrunk it down. The rule of transformation. In here, we're looking at what we have as far as we've got the two figures now. We need to know how we've gotten one place to another. Now, it's kind of hard to see. This is a prime, there's a prime, and then there's a K prime here. And that's important to know. We're moving from this point to here. Now notice the K and the Z and the I are all on the same side. They're all the same. Nothing's flipped. It could be a slight turn, but really it looks more like a translation. So we're going to translate this figure into the new figure. So how did we do that? So how many did we move from right to left? So let's see, we moved 1, 2. So we're taking x plus 2, or you could say x, you could say 2 to the right. And then we go down 1. So it's a y minus 1 or down 1. So you could choose either one. Either you choose this side as your translation, or you choose this here, 2 to the right and down 1. And this is our answer. So when we ask for the rule of transformation, we're asking which transformation it is. We're telling us it's the translate or translation. And how do we translate from one figure to the other? 2 to the right and down 1. Or we can translate x plus 2 or y minus 1. Both answers are okay. Don't mix them up. 2 plus to the right and y minus 1 isn't correct. You either choose one method or the other. When we're looking at here, you can see that we've kind of tipped our section over. We've kind of tipped our section. And again, these are primes in here. So this tells us this is our pre-image and this is our image. So when we're translating this or we're taking our transformation, we've kind of tipped it over. So you can kind of see that we're looking at this as a rotation. So this says rotated, and then we need to know how much. So we go from one coordinate to the other, and we've gone from this side to the other. So when we've moved one coordinate, that's 90 degrees. Which way did we go? This way, which means that we've gone clockwise. And then we used our about the origin. So that's the part that's holding our string. We're moving it, our little string right here. Each one is moved, and it's moved based on this being our vertex. You can see right here that this is our 90 degrees. If we were to do the same, we would make it bigger, 90 degrees, but it would still be a 90 degrees. So this is our rule. Which transformation and how do we move it? And for rotation, we need it about the origin. Right here, you have the A prime and the B prime are over a line. It's over this line right here, and this is called the x-axis. So each side, it's kind of flipped right here. They're not on the same side as what we have up here. They're all the same. Everything is in the same direction here. There, you can tell that it's a reflection, and it's over, and our line of reflection that we have right here is right here, which is the x-axis. The x-axis. It's reflected over the x-axis. So everything from the image is on one side, everything from the pre-image is on the other side. That's our reflection. Okay, the last one we have in here is the dilation. When we're looking at here, again, these are the primes. We need to see, so we need point B. Let's see to see our lines in here. I'm going to do point A think. We need 1 point from the old circle and 1 from the new. So in here, A is -2, -2. And then B is, or excuse me, A prime, it changed into A prime is -4, -4. So when we're looking at this here, it's like what times -2 would give us our -4? What times -2 will give us our -4? So we can see that we did 2. -2 times something gives us a -4. And we can see that when we put in here, that would be 2. And everything is multiplied by 2. So that's our scale factor. Another way to find that is to take our new point, which is our prime, over our old, which is -4 over -2, which gives us 2. But we can also see it in here. So our scale factor is 2. But that's not our full rule. We have to name our dilation, which is our type of transformation, with a scale factor of 2, because that's what we found. 2 times every number gives us our new triangle, and it's centered around the origin. Okay, so that's it. You do the U-tries and then show them to me. Good luck.